Hey guys, today is Thursday, October 1st, and we're going to do a lesson on polyhedron today. So I'm going to share my screen. Okay guys, so today is Thursday, October 1st. When you double click on today's date, you have your attendance here. Your video lesson will be posted here. Then you have the slideshow, some notes for your math notebook, and your assignment for today is right underneath that, complete and submit assignment 10-1. So you'll complete that and submit it on Canvas, and then we'll go over it tomorrow. Okay guys, today we're going to learn about polyhedra. Our learning goal is let's investigate polyhedra. And your targets for today, I can describe the features of a polyhedron using mathematical vocabulary. I can explain the difference between prisms and pyramids, and I understand the relationship between a polyhedron and its net. So what is a polyhedron? A polyhedron is a three-dimensional figure with faces that are polygons. Each face meets one and only other face along a complete edge. The points where the edges meet are called vertices. The plural of polyhedron is polyhedra. A polyhedron always encloses a three-dimensional region. Here are some drawings of polyhedra. Okay, so down at the bottom we have polyhedra. A cube is also a polyhedron, and a rectangular prism is a polyhedron. And then some other examples of polyhedron. This is an octagonal pyramid. So notice the face on the bottom is an octagon, but it creates a pyramid by meeting at the top. It's a triangular pyramid. The base is a triangle. It meets at the top at a point. This is a square pyramid. These are all polyhedron. This is a, hexagonal prism. Okay. Hexagonal prism. And then this is a triangular prism. It's different from a pyramid. We're going to talk about the difference between pyramids and prisms in just a little bit. So some vocabulary that you're going to need to talk about polyhedron are face. We've already talked about that. We talked about it Monday. A face is any flat surface on a three-dimensional figure. So this will be a triangular face. On this shape, this will be a hexagonal face. On a cube, we have faces that are squares. On a prism, we have faces that are rectangles. So on the drawing, each one of those sides are called faces. So we've got a blue face that's a square, a red face is a square, and then over here, a yellow face that is a triangle. Then another vocabulary word that we need to be familiar with is edge. An edge is a line segment on a polygon. It is also often called a side. A line segment where two faces meet in a polyhedron is also called an edge. So on this rectangular prism, the edge is here, where the two faces meet. So this would be an edge. This is also an edge, where the rectangular face meets the square face. Pyramid has edges as well. Where the two triangular faces meet, that's the edge. And then also the two different triangular faces, the larger and the smaller, where they meet, that's called an edge. And also the word vertex. The vertex is a point where two edges meet on a polygon or a polyhedron. So a vertex could be the tip of a pyramid, or one of the bottom corners of the pyramid. That's a vertex. There are vertices all around the edge of this octagonal pyramid, and it meets at a vertex. Okay, so now we're going to talk about two other vocabulary words that you need to know. One is prism. And a prism is a type of polyhedron with two parallel faces that are identical copies of each other, connected by rectangles. Okay, so for example, this is a prism. One side is a square, one base is a square. The other base is a square, so those are opposite sides. They're parallel, they're both squares. See if I can show that in the video up here at the top. And they all are connected, the squares are connected by rectangles. So prisms their bases are connected by rectangles. Here's another example. This is a triangular prism. The bases are both triangles. Let's see if you can see that a little bit better. There we go. The bases are both triangles, and they are connected by rectangles. For this one, it's a hexagon base, and the hexagon bases are connected by rectangles. So if the two bases are connected by rectangles, then it's a prism. A prism is named for the shape of its bases. For example, if the base is a pentagon, then it's called a pentagonal prism. Here are some drawings of prisms. The bases of this prism are triangles, so it's called a triangular prism. The bases of this prism, the bases are pentagons, so it's a pentagonal prism. And the bases of this prism are rectangle, so they are rectangular prisms. Now, some polyhedron are called pyramids, and a pyramid has a special face called its base, and all of the other faces are triangles, and the triangles meet at a single vertex up at the top. For example, this is a pyramid. The base is a triangle, and all of the base is connected to the vertex at the top by triangular faces. The same thing with this one. It has an octagonal base, and the octagonal base has sides, faces that are triangles that are connected by one vertex. And for this one, it has a square base, and it is connected to the vertex at the top by triangular faces. So this would be a square pyramid. So the difference in a pyramid and a prism is that the faces that connect are all triangles, and they're connected at a point, at a vertex. For this one, the prism, the bases are triangles, but they're connected by rectangles. So pyramids are connected by triangle faces, prisms are connected by rectangular faces. And then we also have the vocabulary word net, and a net is a two-dimensional representation of a polyhedron. It can be cut out and folded to make the model of a polyhedron. Here is a net for a cube. So the blue one is a cube net. Then you have all of these other types of nets. This one is going to be a, let's see, 1, 2, 3, 4, 5, 6, 7, looks like 8, so octagonal prism. This one is a square pyramid, and then this one is going to be a triangular prism. We'll talk about nets a little bit later in the slideshow. So what are polyhedra? This slide shows some examples of polyhedra and some non-examples of polyhedra. Look at the top row. All of the polyhedra on the top have polygon faces. They're connected by edges and vertices, and they all have straight faces or straight edges. Pictures that do not represent polyhedra are at the bottom. A sphere is not a polyhedra. While it is a 3D figure, it does not have polygon faces. The same with a cylinder. A cylinder is a 3D figure, but its faces are not polygons. Remember, polygons have straight edges. The third figure is really cool, but it has curved edges, so it is not a polyhedra. And the last figure looks like it could be a rectangular prism, but if you look carefully, you can see that it has no top. A polyhedra has to be a closed shape. Here are some polyhedra called prisms, and here are some polyhedra called pyramids. Look at the prisms. What are their characteristics or features? So you can see on each one of these, A through F, we have polygon faces, and the bases are all connected by rectangles. So this prism has triangle faces, and it's connected by rectangular faces. So this is a triangular prism. Letter B is a cube. We know cubes have square faces, and they are connected by other squares. So we know that is a cube, and it's also a rectangular prism. Letter C is another triangular prism. Its bases on this side and this side are both triangles, and they're connected by rectangles. Oh, excuse me. Here we go. Okay, the next one is hexagonal prism. Its bases are both hexagons, and they're connected by rectangles. E is a square prism. Its bases are squares, and it's connected by rectangles. We could also call it a rectangular prism. Letter F looks like a hexagonal prism because the bases are hexagons, and they're connected by rectangles. P through S are all pyramids. All of the pyramids have a base, but the base is connected to a vertex by triangular faces. So letter P is a triangular pyramid because its base is a triangle and it's connected at a vertex. Letter Q is a square pyramid because its base is a square and it's connected at a vertex. R is a pentagonal pyramid. Its base is a pyramid and it's connected at a vertex. And letter S is a hexagonal pyramid because its base is a hexagon and it's connected at a vertex. Next, I have some videos of nets of prisms and pyramids. So I'm going to click on each shape, and then we're going to be able to look at the nets of each. So the first is a cube. When I open the cube, oh, it's taking a second to load. Here we go. When the cube is unfolded and laid out flat, it creates a net of the cube, kind of like wrapping paper. And you can see that the cube is made up of 6 squares, 6 identical squares. So looking at a net can help us to figure out what the surface area of a particular polyhedron is. All right, let's look at the next one. This is a hexagonal prism. And when you unfold a hexagonal prism, you can see that it is made up of two hexagons, the hexagon bases. And those bases are connected by rectangles. So when you unfold it, you can figure out what the surface area is by looking at the base and the height of the rectangles and decomposing the hexagons into triangles or rectangles. So knowing what a net looks like of a polyhedron will help you figure out surface area. The next one is a rectangular prism. All right, so when we show the net of the rectangular prism, it looks really similar to a cube. However, it has rectangular bases. So you can figure out the base and height of each of those rectangles, add them together to figure out your surface area. And the last is a triangular prism. Okay, you can see a triangular prism has two triangle bases connected by rectangles. When you close it up, you can see the triangular prism. It's not a pyramid because it doesn't meet at a vertex. And it doesn't have all triangular faces. It has two triangular bases connected by rectangles. That makes it a rectangular pyramid. So you can figure out the surface area of this triangular prism, by figuring out the base and height of each rectangle and then doing 1/2 base times the height for the triangles. All right, nets for pyramids. So how do they look different? This is a square pyramid. You can see the square base and the triangular faces. When you close the square pyramid, it looks like this. So it meets at a point or at a vertex. It's open. When you close it up, it meets at a vertex. And this is a triangular pyramid. You can see the triangle base, and it's going to be connected by triangular faces. Well, it's not letting me. Let's try refreshing. Let's try it again. If it doesn't work, we'll just skip it. There we go. So they've closed it in a different way. But you can see that it's made completely out of triangles. So we know if it's completely made of triangles, it's going to be a pyramid, a triangular pyramid. Here's another net. So it just opens from the top. All right, and the last one is I believe it's a hexagonal pyramid. I'll have to count the sides and see. It might be a pentagonal pyramid. Not sure why the internet is so slow this afternoon. Oh my goodness. Let's see if we can pause this. Okay, so let's try this again. There we go. Here he is. Okay, so it is a 1, 2, 3, 4, 5. It is a pentagonal pyramid. I'll wait for it to stop turning. Well, it just wants to be so slow today. Here we go. So we can see that we have a pentagon base with triangles touching each edge, and they are going to come together at a vertex to create a pyramid. So this is a pentagonal pyramid. Oh, look, I can change it. Here's an octagonal pyramid. So when we open, we can see we have an octagon base, and each of the faces are triangles that come together at a point, at a vertex, to create a pyramid. Okay. All right, so now I have some paper examples of pyramids and prisms that I'm going to share with you. I'm going to open up my overhead. There we go. All right, so here we have two triangular bases, and they're connected by these look like squares, but let's just say rectangles. So what type of shape is this? Is it going to be a pyramid or a prism? All right, so if I fold it up, I can see that it meets at an edge. The rectangles meet at an edge, not at a vertex. So this is going to be a triangular prism. A triangular prism, because it does not meet, the faces do not meet at a vertex. They meet at an edge. So we have a triangular prism. Next example, I have a triangle that is surrounded by other triangles. Is it going to be a pyramid or a prism? When we fold it up, we can see that it is a pyramid. It's a triangular pyramid. The base is a triangle, and this triangular faces meet at a vertex. So it is a triangular pyramid. So that's a triangular pyramid. And this was a triangular prism. So when you hold them like this, they look the same. But when you turn them to the side, Oops. You can see one meets at a point, the other meets at an edge. So prism, triangular pyramid. All right, let's look at this one. All right, we should start recognizing this guy. We have a square base, and it is surrounded by squares. So we know this is a cube or a rectangular prism. When we fold it up, we can see, hard to hold on to. We can see the cube. We can see the square bases that are connected by other squares, and they do not connect at a point. So this is a prism. Okay, for this one, we have a square base surrounded by triangles. So you've probably guessed by now, this is going to be a pyramid. So when we close it up, we can see that it meets at a point, has triangular faces, and it has a square base. So this is a square pyramid. Okay, so if it meets at a vertex, it's a pyramid. If it meets at an edge, it's a prism. So prism, pyramid, it meets at a vertex. Okay, so to sum up our lesson for today, polyhedron are 3D shapes made of polygons that meet at vertices and edges. A pyramid is a polyhedron with one base that determines the type of pyramid that it is. The other faces are triangles and meet at one vertex. A prism is a polyhedron that has at least two identical faces that are parallel and determines the type of prism that it is. A net is a 2D model that can be created out of a polyhedron to help identify the type of faces on the polyhedron. So you need to think about your best definition or description of a polyhedron. You can use the terms that we've learned in the lesson, like base and edge and vertex. Looking at number 2, which of these 5 polyhedra are prisms and which are pyramids? So first, take a second and think about which shapes are prisms. Which of these shapes are prisms? Remember, prisms are connected by rectangular faces. So the prisms are going to be A, C, and D. That means the pyramids are B and E. We know those are pyramids because they meet at a vertex up at the top. And they have triangular faces and one base. So this is a rectangular pyramid, and this is a pentagonal pyramid. So what's next? Next, you're going to go into Canvas. You're going to complete the assignment for October 1st. Practice problems for Lesson 13. Tomorrow, we're going to go over Lesson 13, and you're going to complete IXL EE1. If you end up having some extra time today, you can work on IXL EE1 or any of the IXL objectives that we've had due prior to today. I hope you guys have a great day, and we'll see you tomorrow.